Hello, everyone, and welcome to the webinar. We will start in just a few moments from now. Thank you. Hello, everyone, and welcome to the webinar. This webinar is actually part 3 of programming with these on Swiss type parts. And again, this will be given by Marina Vilkina. This webinar, as always, is being recorded and will be available afterwards on our website. Okay, Marina, I will make you the presenter, and you can go ahead and just a moment. Here you go. You can go ahead, show your screen, and start.
Okay, thank you, Sydney. Double check, as always. Can you see my screen?
Not yet. Yes, now I can see. Go ahead.
Okay, nice. Hello and welcome to the webinar. Today I will show some advanced options for Swiss type machine. Actually, we are considering a citizen machine, and today I'm gonna program such operations as long drill, long turn, and inclined milling on a back spindle. And also I would like to convert a COM part from one machine to another. So let's start. Here I have a half done COM part. This is the same 3D as we used during the session 1 and session 2, but if you look more closely, you will see that machining sequence is reversed for this particular COM part. A cutting process starts from this side. This side was the back spindle side during the previous session. Now this side will be cut on the main spindle, and my inclined faces are located as they should be cut on a back spindle. Also, I would like to perform a long drilling of this hole, and this will be the first operation which I'm going to add to the COM tree. But before I will add it, I would like to consider the sequence that we have here. The first operation is a face turning. Then I have a OD turning, just a part of the 3D. Then it will be milling with the axis, but it will be reversed, and it will have a 0 position for this operation. Then I will have OD turning again, one cut, then some radial, the wrapped pocket here. The sequence that we considered during the previous webinar, the cutoff operation, and then some turning operations on the back spindle, facing turning, milling with the face, and the part ejection. Let's check machine simulation. I will show you the synchronization table. So this is the common sequence without the synchronization of 2 channels. So this is like we will start this project, check simulation. So you can understand what I'm going to do here. As I said, it's a half-done COM part. I will add a long drilling, and then I will add one more operation on the back spindle. Okay. This is it. So I will just quickly show you what is going on here. Then I have milling with the axis, even it is rotated with the 0 position.
Marina, are you there? Because we can't hear you.
Can understand the sequence which is always used for this particular machine. In some other machines, it may differ, commands may differ, of course. It's Mitsubishi CNC. And this is the piece of the process. First of all, we have some movement. There is no tool call here. This is the movement of the stock. We position the stock, the Z1, to the position of the cutting. During the long drill, I can use two modes on this machine. I can perform the drilling with the stock movement, so tool will not move. And the second mode, which I'm gonna use, is
Marina,
the
can I stop
movement
you
of
just
the
please
tool
for a
itself.
moment?
And
Marina, can I
my
stop
stock
you for a
will
moment,
not move.
please?
So I
Marina?
should position the stock. I should pull it out from the collet. Then I
Marina?
should shift my coordinate system. Then I will turn on the rotation of the tool and also of the stock. Then I should go to the second channel, turn on a special passive button. This button is always used for this operation, G620. And then I can call my tools and perform, as always, the drilling operation. I can use cycle, I can use G1, G0, whatever I like. I should retract tools, and then I should go to the source channel again and retract my stock back to the collet or whatever I like, and shift the coordinate system again with the same values. So it is clearly that we should have three blocks to program this process. Two blocks on the source channel and one block, the operation itself, on the second channel. And this is what we should perform inside the COM tree. So to add operations here, this tree is ready, and I even have part eject operation at the end. I will suppress this operation. And now, as you can guess, according the sequence of program, I should add the MCO operation to position my stock, because it is not a operation itself. I'm not going to cut here. I just want to position my stock and turn on a rotation of the stock for this operation. So I will go to machine control operation. And of course, here I have a list of MCO. And I have the MCO, which is called like before, preparation to this special mode. And here I have some parameter list, and the main parameter is the position, the movement of the stock, and the direction and the value for the rotation. I will apply that. The next operation is the cutting operation. This should be a drilling operation itself. So I'm going to turning operations, go into drilling. So this is common process, and I will use Mach 1 because even if I'm gonna program this on a second channel, the part will be located on the main spindle, and I'm gonna use the coordinate system of the main spindle here. I will select the tool for this center drilling operation. Center drill. I will change the name also. So T21, I will remind again, it is located near the back spindle. T21. Select it. Then levels, technology, for example, -2. I can use the drilling cycle here or will not use it, as I saw inside the program example. So, and I'm going to links, and I should be careful with links here because, as you can understand, this link will be performed with V2 movement. That means that back spindle will move, and this is not the stock movement. Stock will stay where it is, and V1 will be in the position which is programmed here. And I should be careful because I should think about the retracting distance for the tool change, for example. So I will put here like 10, and for example here I can, for the tool change, I can use some other values like this. For example, I can do this. Okay, I forget to rename this. Okay, this is center drill, and next operation will be a G83 cycle, a longer drill, and I will call it like drill D5. And here I should change my tool. I will use the drilling tool, the longer tool. And inside the technology, for example, I will use some other values here. And in drilling cycle, I would like to use cycle, and I would like to use some step here, and I would like to have the output with cycle. And on the retract position, I know that this operation will be the last operation for this tool block, and this tool block is a back spindle, so I would like it to retract as far as possible because maybe for the next operation I need to move my back spindle somewhere. So I prefer to make it like longer retract. And the last operation in this block is MCO operation again, because according the program example, I need to retract my stock back to the collet. This is what I'm going to do here. I have a stock move MCO, and this is the position for the stock. What else I should do here before calculate other three? Because here I have what is called the combination, and by default the combination which is used is the combination for the first channel. That means that I will have the movement of the stock, not of the tool movement. I don't want to move my stock, so I'm going to change submachine, and I will use
Okay, everyone, we seem to be having a little bit of internet problem. Hold on a moment and we will try to reconnect her.
machine that I programmed the machine with the X2 Z2. It will not use Z1 here. This is very important. So I will use this type of cycles, and also I should change the patterns for the part transfer. I showed it during the previous webinar, and that's all. Now I can check machine simulation, and then I will go to change operations on an Extendo. For such type of operations, machine simulation is critical because you can check the positions, the outside of the lane for the tools, and to check if there will be no gouges during the process. Maybe tool is too long, maybe you should use some other type of the holder. So it is very important. So let's check the simulation. I will have my space, and after that, as you can see, I have my center drilling tool. I will go a little bit back, and so here my stock is pulled out from the collet, 15 millimeters. I called my T21 tool, and my stock will not move. My Z2 will move. So this is what we call a long drill operation here. This is my safety retract. And now the other operations, which you saw previously. I will stop it. So very easy, but you should know what the requirements of the machine for such type of operations, of course. The next operation I'm gonna add is incline milling. So the B axis tool holder should incline, should rotate, and the back spindle should go there to perform this operation. I'm going to perform it after the toning, of course, so I will unsuppress my toning operation. I need this space to be cleaned before this operation, so I will unsuppress my toning operation, and after that, I'm ready to add the inclined milling. Before I'll do this, I will show you the programming example. Again, this is important, I think, because the examples, what machine needs is really depends from machine to machine and from controller to controller. This is Citizen with Mitsubishi controller, and this code example is like a base for whatever we would like to add to the COM tree, because it really depends on the machine. So what is needed here? First of all, I do not need any special access templates, machining templates, access patterns. I will use the common neutral G600 pattern. I will not have any operations on a main spindle because to perform this operation, I will need X1, Y1, and B1 from the source channel, and Z2 and C2 from the second channel. And all I need to do is just call my tools in the second channel, and I can easily program all access that I need. I will show you what I'm going to do here. I will go to the last turning operation on the back spindle. I will go to machine preview to make it more clearly. So after this operation, I have my stock right opposite my T31 tool. So this is the tools and access that are controlled on a back spindle on a second channel. But what I need is these tools. And as you can see, these tools are connected with the source channel and with gang. So this is X1 or Y1 and B position. Normally, they are programmed in the source channel, but because I will use Z2 and C2, my stock inside the Extendo, I need to combine all these access together. And on Citizen Machine, all I need to do is to call the access button G600, and I can write down all accesses together in one channel, but all I need to do is to call these tools. So for the solid cam, I need to position my stock right opposite the main spindle, and then I can use these tools. And I will add just one MCO to position my stock right opposite the main spindle. I will go to machine control operation. I will go to T50 on back spindle. Will position my back spindle for the B-axis cutting. And now I can add this operation. The operation will be added with the same way as during the first session as I did it on the main spindle, nothing special at all. I will just go to milling, I will go to profile, then I will use Mark II. I will have to use Mark II because this is programmed on the back spindle. And to be honest, I need Mark II and 2 because I will need the Z-axis, so which is perpendicular to the first face. I'm gonna mill because I have 3 of such faces here, and I will add my contour, my profile chain here. Absolutely the same process as for the main spindle. What else I need? I need to add my tool. This will be the tool 52. I will show it again. This is it. So this is it is right opposite the tool that I used during the first session for this inclined milling, and this tool is used for the face milling in this part on the main spindle. I will go to levels as always, and in the technology I will move a little bit my chain here to make it in one cut, to not make my cutting too long, and I will use it like tangent, and that's all. Now I should add more copies. I will include original, add angle, add number of faces here. So very simple process here. And I can unsuppress other iterations in the country. My next operation should be T33. So this is the back spindle tools, and they will perform some operation with the axis face operation, face cutting, and I have part ejection here. It is simple in the country, but I have a message from my channel synchronization table, of course, because I need to change the axis button. I need to control to help my machine to understand what axis it should use for this operation here. First of all, I will launch this process step by step, the first channel, then second channel, and then I will mix operation and make some synchronization in the channel. So what I will do here, my favorite button, and now I will put like G620. Here, this is the transfer process, the common access buttons. But for the back spindle, I need to apply some other types of weight marks. I need to separate the operations with the B axis and with the T33, 31 tools, because this is different locations and different axes will be used for these operations. So I will just separate them with weight marks, and then when I will have my weight marks, I will add some other types of patterns. I can add them. For the first run, I can leave it as they are, because for the machine, when it is calling the tool number, it will understand what it should do there. Okay, I have one message about, yes, this is what shouldn't be here, and I will join them. Okay, that's all I need. I don't have messages about clashes. And now we will run the simulation, and then I will show how to mix operations inside the channel synchronization table. Okay, so this is what we saw previously. It should be facing, then long drill, then turning again, milling, milling, turning, then milling again, radial milling, part transfer, turning, and then I will have my B-axis operation on a back spindle. So this is what I have here. This is why we need machine simulation for such type of operations, to check the positions of the tools if they are not intersect each other. So I will have my operations, and then my stock is going back to this tools for the milling and goes to the part eject process. But of course, I would like to perform it more effectively. I would like to run this process like a parallel process. For example, here we have a lot of facilities to mix these operations, but I would like to mix it. The long drilling and B-axis, because I don't want to retract my B-axis back to this tool block, and then again for the main spindle. I would like to launch together turning operations on the main spindle with turning operations on the back spindle. Then I would like to perform a long drill operation. Then I would like to have my B-axis operation, and after that my stock will go back to the T32, and I will launch other operations on the main spindle with milling operations that I have on a back spindle. This is what I would like to do here, and it's not very complex to perform this. First of all, I will add a new workpiece because I would like to launch together these turning operations on the back and on the main spindle. I will just add a workpiece, delete the synchronization label here, and here I will use the weighting mark, which is called synchronize selected operations end to end, because I would like to end these two turning operations together. This is just one of the types of synchronization that you can use. You can use some other sequence, for example. Then I have the preparation for the long drill on the main spindle, but here I have operations for the B-axis. I would like to move my drilling operations and I would like to put them before the B-axis. I will just take them and move. And I remember that my drilling operations should be run after this preparation MTO cycle, and I will use the synchronization from start to end. Then I will need my stock movement after the last drilling operation with T22. I will apply my stock movement and drilling. We'll just delete extra weight mark, which I don't need here, and try again. Now I need to position the B-axis after, for example, this stock movement, because I don't want to retract my stock back to the catcher. After that, I would like to perform, for example, my face milling with, I don't know, for example, hexagon face together. And what else I will need? Something like this. And what messages I have here? Okay, I will delete it and put it again. Yes, and I don't have any messages here, but I need to add additional weight marks, okay, to synchronize them for the Citizen machine. I will use it because I would like to launch both channels, turning operations in both channels. I will need G630 access button here. This access button should be G600. For, as I said, for the long drilling, I will use G620, G600 again. Okay, I don't need turning operation together with the axis positioning. I would like to put them, for example, like this. I don't like it. Okay, I will put my I would like to change that. So I will put my turning operation, for example, together with face milling. Okay, and like this. Okay, this should be G600, 600 again, and this one should be G630, 600, and this is my transfer codes. And that's all. I will launch my simulation to check if my retract are okay and tool will not gouge. I can add more MCO cycles, for example, for retracting the spindle, retracting stock, retracting tool, whatever I need if I will find that something will go wrong during the synchronization. Also, I can save this table of synchronization and to change some other, check the time, for example, and to try different versions. So here I have my turning operations together. As you can see, facing on the main spindle is completed, but it will wait till the turning operation on the back spindle will be complete. Now I have my long drill operations. I have my B-axis operations here. Maybe I will need to retract the B-axis. This is up to the programmer, whatever you like, if you need the retracting. And also my milling operation here is done, and that's all. So it looks not bad, but you can change logically, and system will not let you to put the operations if they can be synchronized. You will see the message here that, for example, this operation can have such type of order, or for example, I can't apply the center drilling together with movement of the stock or something like that. And I can save this this synchronization table. I can export and import it, try some other whatever. So it's very powerful tool to show. The next advanced operation I'm gonna show you, we are calling it like a long tone, or also it is called like superimposition for the axis. I will open some other project here, which is called long term. This is a very simple part. I will focus just on the operation itself. So what long turn does for the machine? The long turn is used for cutting the long parts when they are clumped together. So it makes the system more rigid and helps to control the form of the part. Especially it is important for the parts with the small diameter and when they are long. And you can perform some operations together into spindles. That means that Z1 axis will be the main or master axis for the back spindle for Z2 axis. Z2 will moves together with Z1 axis, and you will program just Z1, but Z2 will repeat all movements like Z1. This makes the process more rigid. Also, this mode is always used on Citizen and some other Swiss type machines for the cutoff process. For example, if you will put the wrong value to the Z position of the tool, but you will turn on the Z superimposition mode, nothing critical will happen because Z2 will move after the Z1. And for the cutoff, it is always used, for example, to perform the cutoff with the chamfer. It is a very common type of the operation, and I will show it today. So I will delete the operations that I have here to show you how to create this type of the operation. I will leave only the common spacing operation and some OD toning here. I'm gonna perform this cutting of this groove with the superimposition mode, and also I will perform the cutoff, of course, with chamfer. So what I'm gonna do here, I will not apply any special machine control operation. This will be, for this particular machine, this operation will be the same as for the part transfer. I need to call my tool, but in this case, it is not a cutoff tool. This is the tool which I'm going to use for the grooving, because inside the synchronization mode, I can change my tools. There is no restrictions inside the CNC controller to change the tools during the superimposition mode. I will call my tool for the grooving. This will be the same tool as for the cutoff, but they may differ. I can use OD turning tool, whatever I like for this type of operation. Then I need to position my groove tool, and in this case, this will be the position like from which the grooving will start. And my preposition, safety position for X-axis. Then I will add one more MCO. This will be the MCO for part clumping. with back spindle. Let me check the position of the back spindle for the clamping. And this is it. So this is how my part will be clamped. It is clamped in both spindles. This is the first spindle. This is second spindle. It is clamped. The clean surface, which were cut during the turning operation, and now it is very rigid system, and I'm gonna perform the grooving operation and cut off here. But this sequence will be the same as for the cutoff and for the long-term operation. And what I'm going to do here is the main command is a synchronization mode for V1 and V2. For the citizen machine, it is just applying the access button G650, but to perform a good simulation here, I will need to add this MCO cycle. And after that, I will not add the cutoff operation. I will add the grooving operation. I will go to turning and grooving. And here I will create my chain for the cutoff, for the grooving, sorry. I'm going to tool. I should select the same tool, which I selected here for the process. And I will use the wrap technology, for example, I don't know, some parameters here, low ones. And also I would like to perform some finishing operations and the links. Here I should be careful with links because I have only desynchronization mode. I didn't synchronize the x-axis, so I will. I'm not gonna. If I will leave some safety corner here, my stock will go back to the collet, but it is clamped with the back spindle, so it may gouge or machine will give you the error message. So I will put X only, and I will leave some safety values here and just calculate it. So this is my operation, and I will just add one more operation. It will be cutoff operation here. And then we will check machine simulation. I will go to cutoff, and here I will add a very common process of cutoff. Tool, the same tool here, levels, technology. I would like to add a chamfer here just to show you the process, how it can be, because it is very useful. It is common also to perform a chamfer during the cutoff if you have two axes and you can control both of them. So I will use it like right side, and I will leave it like a small chamfer here. And here I will use the same safety position. And as you remember, if you remember, it should be none here for the cutoff process on a Swiss type machine. This is my cutoff. I must turn off my synchronization mode. So I will choose to turn off. Then I will retract the back spindle with the stock. And I will need to change the bar on the main spindle. I will not add part ejection because I'm not gonna add operations on the back spindle. So this is, as you can see, my chamfer. I will go to channel synchronization. I will check my synchronization type and the access buttons, which I used here. This is it. Very common process. just several clicks, and now I can launch the simulation. So let's look more closely how it should happen here. Just run the first operation, spacing, turning. Okay, here I will have the tool retract. Okay, I will stop that. This is the preparation of the process. The part is pulled out of the collet. The tool is ready to cut. It's 40 millimeters diameter. This is the position, safety position, and then clamping position for the back spindle. And this is what is going on here. The part is moving and two axes are moving. The main axis here is Z1 and Z2 is moves together with Z1. So it's the slave axis here. I will just run it. And it can move in both sides, but of course we have limitations because of the axis itself and because of the collet. So it's quite complex operation. It has some limitations which can be found inside the programming manual, but inside the SolidCam it is programmed very easily. For example, I can add operations if I will add an operation under the synchronization, and will take care about the tool call and my retract of the tools. Nothing more will needed here. I can just move it in the country. And the last part of this webinar is the part converting. So I will open a project which is done on Citizen machine, and I will convert it to some other machine. Let me check where it is. Just a second. I will just open it manually. Okay, hope this is it. Yes. So this is what we have here, a part which is cut on Citizen machine again. I have a face operation here, some operations with the long drill. So this is the back spindle tools are cutting this part. Then I have some turning operations, radial milling, and some turning again, transfer, and operations on the back spindle with turning and drilling and also milling. I will show the simulation very quickly. And the machine which will be to which I would like to convert this project will differ from the Citizen machine, and it will have a different number of tools, and position of tools will differ. And I will show how to change the project during the converting. Okay, I will run it. Turning, milling, turning again, part transfer. I'm turning, drilling, milling, that's all. Now I will choose some other machine. And to do this, I will go to Compart. And I will use this machine. It's Chamfer 20RBY. It doesn't have the B-axis, but it has a holder with the drilling tool. So the first question which I have from this system is to submachine conversion. This is the list of the submachines from Citizen, the original project, original machine which is used in the project. And this is the list of the tools and submachine that I have inside the new machine. And as you can see, the new machine has less tool holders and submachines than the original one. And but the part converting wouldn't be very hard. It will be it is easy because of the machine preview function that we have inside the SolidCAM. So you need to know what submachines can be used. For example, this submachine is the submachine for OD toning. If my gang submachine will support it, yes, it will. This is submachine for the radial milling. Yes, my gang will support it too. This is submachine, the tool from the back spindle. I don't have this tool from the new machine, but I have a special tool holder on the gang, and it will support. This is tool for the back spindle. I have completely the same holder on the new machine. So I will just apply it. So it happens automatically. In some cases, you need to change and choose some other submachine here. So I will just change one submachine. This is a special submachine for turning on a back spindle in the new machine. I will apply that. And also it's drilling cycle conversion. Okay, and we'll just apply it. What is certainly changed here is MCO cycle. The new machine has a completely different controller type. It has a FANUC controller. It is not Citizen, and it doesn't have an access buttons, machine buttons here. And the sequence of part transfer will differ dramatically. Also, it doesn't have, as I said, a long drilling. So I would like to delete all MCO cycles because they differ for this machine. Then I will suppress all operations for the back spindle to not have some messages, error messages during calculating operations on the main spindle. Now I will go to my tool table and I will check how tools were converted. Okay, this is my machine. So as you can see, it is different. It doesn't have the B-axis, but it has radial and axial tool blocks for the milling. Also, it has a special tool blocks for the drilling, OD turning. But this tool block is looks very similar as on Citizen. Besides this tool holder, I will need to change the position of this tool. So let's check what's going on here. My OD tools are located as they are, as they should locate, but I will need to change their position for the milling and drilling tool. The first tool I will change here the position of the tool. I'm not going to change the tool geometry, just tool position, and maybe holder itself. It's tool number 8. It's a milling tool and it is used for radial milling, and I need to put it here. This is T20 tools. I will put it like T21. And because of the orientation of the tool holder, I need to change it. And this tool holder will not use on this machine. I will need some other tool holder, especially for this machine. So I will go to holders and we'll try to change it. So I will use the global database, this machine, and for example, this tool holder, whatever you like. So just click on your holder. And I will change the tool number here. The next tool is my drilling tools, because they should be here, and I'm gonna drill with this gun tool table. So I will put it to, for example, T11 position, and maybe I will need to change the tool holder, but I will leave it as it is. And I will change the tool number also here. And I will go to my center drill and will change the tool position also. We'll put it to the same tool table. Okay, the next tool I would like to change is the turning tool for the back spindle, because the tool position should differ here. It should be rotated. First of all, I will change its number, and then I will change a little bit its direction, and I will use the X direction here, and also I will change the tooltip position a little bit, like -20, -12, and I think that's all. I can use some other station. There are 3 stations for this tool table, and that's all. I will save that. I have the message from the system that this tool will be used for the facing operation on the Extendo. Yes, I will change that. The next step here is to check the lead in, lead out, retract of the tool. And the first tool is the drilling tool here. Because it was used on the next spindle, I need to check my retract. It's just Z2. It means in the previous project, Z2 means that back spindle will be retracted in 2 mm out from the face of the main spindle. But in this project, that means that my stock will go inside the collet in 2 mm. It's okay for me, but for the next operation, it says that my stock should go to the collet in 100 mm. It's too much for this operation, for the stock also. And I think I can calculate all these operations, but I need to add a transfer process here because it is different on this machine. So this is my cutoff operation, and I will need to add my transfer after the OD toning. I will go to machine control. I will go to my list of my cycles, my preposition cycle. Machine is different from citizen, but cycles are very similar, and the process is similar. So I will go to my tools and select my cutoff tool. It's T1 again for this machine also. This is the rotation for the cutoff. For X movement, I will use 20 also. Z movement, this is the position for the cutoff. And I will use this position, and we'll just add a 1 mm to have a allowance. Okay. Now I will add the synchronization. This is MCO for synchronization. In this machine, it should be additional MCO, and it has a wait marks at the beginning and at the end. So this is the speed of synchronization for two spindles. And the next MCO is for clamping the stock in this clamp position. And here I will apply the set application. I will calculate that and check. Okay, how I can check this? Something like this. So this is my position for the cutoff. This is the position from the setup. Okay, synchronization, I think it should be used here. So I will edit like synchronization on cycle, and this is my cutoff. It will not change. I will add the synchronization off process. Then I will add a retracting of the back spindle, base home of the transfer cycle, and some bar change on the main spindle. This is, as you can see, a common sequence for the three type machines, but G-codes will differ from machine to machine, but cycles look similar. Now I can unsuppress these operations here and check recalculate them. Okay, looks not bad. So what I have here, I have my spacing operation with radius. Let me check the retracting. I would like to make it like normal. Okay. Change that. And I have some drilling operations here in the milling mode, chamfering, and some milling on the back spindle. Now I will go to my synchronization table because I have a message from a system that is not good. We'll sort it, and there will be no additional access buttons here, as you can see. This machine doesn't use it. It has some other cycles and M codes inside for this process. All I need to do is to add additional wait marks before the spindle synchronization and MCO. This is specific things about this machine. What else I can do? I can synchronize these two steps, and let's check what we have here in the machine simulation window. Okay, so this is my stock. I have a turning operation, drilling, turning again. And for this machine, as you can see, the tools for the radial milling are located in some other place. It is rotated on 90 degrees here, but I didn't change anything. I didn't add additional coordinate system or recalculated even the process, didn't re-choose the tool. No, I just put the tool to the right position, and I know this tool can do this. The original position of the axis of the operation were okay for this tool. If it will be inclined, for example, I will have a message from the system that it's impossible to add a 5-axis operation here because this machine doesn't have additional rotation axis. But for this operation, it is okay, and I don't need to add any additional things here. I will just run the simulation, and I have my result here. Okay, next operation I think will be turning again, and then I will have my part transfer process. So this is part transfer. And my operations on the back spindle. Also, I didn't change anything inside. I just changed the position of the tool and recalculate the operation. And I have it done. And also I can apply some synchronization as I did on the during the previous session. For this machine, it works also. So this is it. So today I showed you the operations, advanced operations. Of course, advanced operations depends on the machine itself, on the facilities of the machine. There are a long list of advanced operations that we have depending on the machine. I showed you today a very common operation, for example, the long drill and synchronized the movement superimposition in V1, V2. It is very common. The superimposition with the axis, each Swiss type machine has it, and it is included to the transfer sequence. It is very easy to program it inside the SolidCAM, and as you saw, the long drilling operations and V-axis operation on the back spindle, it is not really complex in terms of programming, but you should understand what machine needs, and SolidCAM can give the machine what it needs in terms of programming, in terms of adding weight codes, adding access patterns, whatever it needs, we have this inside the software. And part converting, as you saw, is very quick process, even if your machines are really different from each other, even if they have different types of tools, different position of the tools. You need just to change the tools, put your tools in a position in which you would like to use them, and to change the MCO inside the CAM tree, and that's all. And take care about lead and link. So it's very, very easy, and you can use it. Thank you.
Okay, Marina, thank you very, very much. It was an excellent webinar, and this, I think, wraps it up for this series. Am I correct?
Yes, this was the last webinar in the series.
Okay, excellent. I hope everyone enjoyed the series, and again, this has been recorded and will be available on our website. Take care, everyone, and have a great day. Bye-bye.